Hey everybody, lesson number 2 here. So we are going to be talking a little bit about the solar system. This is just a general overview of the solar system. We are going to get into some stuff later on in some future lessons about small solar system buddies and other things like that. So let's begin without any further ado. The solar system. So the solar system gets its name from our sun, which is Sol. And so everything is surrounding Sol, and so we get solar system. Now we did have a lesson on the sun, so I'm not going to talk too much about the sun itself. But in any case, so the solar system, as I mentioned, already gets its name from the sun, Sol. We know that there are 8 planets so far. And 181 moons, 173 of which orbit full-size planets, while a couple of the other ones orbit smaller planets. These things include Ceres, Pluto, Haumea, Makemake, countless asteroids, and comets also are included in our solar system. And as I mentioned, most objects already travel around the sun in elliptical orbits. You guys will recall from when you did the Kepler's Law Lab what elliptical orbits are. So here's an image of many of the moons, but again, a small number. So there's Earth's moon, and this is all a relative size. So you can see that the Earth is here, relative size to our moon is roughly right there. And then, of course, we have lots of other moons. So the moons on this diagram here are the major moons of the different planets. So Mars, we have 2 moons. They're really tiny. That's why they almost don't appear on this particular slide. We've got Phobos and Deimos. And then, of course, outside of Mars, we have Jupiter. Jupiter has 4 main Galilean moons, along with countless others. So the 4 Galilean moons are Io, Europa, Ganymede, and Callisto, as you guys can see here. Io is Europa is of particular interest to us, as we think that there is a liquid ocean underneath its icy crust, and so it may be a place which could potentially harbor life. Mimas is one of the small moons of Saturn. It's actually a really interesting moon. If you Google it, you'll actually find a picture of it. It actually looks like the Death Star from Star Wars, which is pretty neat. Enceladus, Tethys, Dione, Rhea. Titan is the large moon around Saturn. It is very interesting in that it actually has a very thick atmosphere. It's why it looks almost fuzzy when you look at this image here. There's a whole bunch of other moons as well. And Uranus, the largest moon around Uranus is Titania. It's got a whole bunch of other moons as well. And then, of course, Neptune, which is our furthest out planet, has Triton as its largest moon. There's other moons, Proteus, Nereid, other moons there as well. Pluto is actually interesting. Its largest moon, Charon, or Charon, I'm not sure how you actually pronounce that, but in any case, it's almost the exact same size as Pluto. Pluto actually has 5 moons, which is really neat. There's some other ones here. And this is a nice little slide here because it represents relative sizes to everything. It actually gives you a scale. So one pixel on this particular image is roughly about 25 kilometers. When we look at the planets in our solar system, we do separate them into 2 major categories. The first category is, of course, small rocky worlds, and then we have large gas giants. If you download the PowerPoint here, these are actual links to spacefacts.com. You'll notice that they actually have individual pages for each one of these terrestrial and gas giant planets. You should definitely have a visit there. It's a really interesting website. Mercury. Mercury is named after the Roman god of speed, right? So the surface is very baked and battered. It has a very thin atmosphere. And so because there is no atmosphere, that means there's not going to be any winds or any precipitation or anything like that to minimize the effects of the surface features. And so when Mercury gets hit by an asteroid or any large object, the crater that's produced is the crater that will be there. It zips around the sun very, very quickly in 88 days. It has enormous temperature swings because it doesn't have an atmosphere to kind of normalize the temperature. So, on the light side of Mercury, with side that's facing the sun, you might be at plus 400 degrees, whereas on the dark side you might be at minus 200. So it's very, very, very huge, enormous temperature swings that happen on Mercury. Next in line is, of course, Venus. So it's named after the Roman goddess of love. It is one of two planets that is closer to the sun than us. The relative distribution of the planets, the first four, so Mercury, Venus, Earth, and then ultimately Mars, is about 50 million kilometers each. So Mercury is about 50 million kilometers from the sun, another 50 million kilometers to Venus, another 50 million kilometers to Earth. We're about 150 million kilometers away. And then as you go further out, Mars is about 200 million or so kilometers. In any case, Venus is the hottest of all the planets. Its atmosphere is 90 times as thick and as dense as Earth's. It is likely caused by a runaway greenhouse effects because of the volcanism that was happening on Venus. And as a result of that, you've got this really dense atmosphere. You've got very, very, very thick clouds of poisonous and corrosive gases. And so what ends up happening is when it rains on Venus, it actually rains down these sulfuric acid rain droplets that are very, very, very corrosive. Venus takes about 0.62 years on Earth to go around the sun once. So about 66% are about 200 days or so, 200 and change days. So it's an interesting, it is our sister planet, almost the exact same size as Earth. And then, of course, third rock from the sun, that's us. You are here. Unfortunately, the image that I picked doesn't actually have a spot where I can say you are here, but there's India and China's here, and up top here is Russia, Turkey, Greece, Italy's all over the place. There's Africa and Australia and the Middle East here. And in any case, that's our planet's a little safe haven, if you will. We truly are a Goldilocks planet. It's not too hot, not too cold. It's just right. It has one naturally occurring satellite. That's the moon, which we call Luna. It has a revolution of approximately 365.25 days, which is why you end up with a leap year every 4 years. You get this extra quarter day that we have to account for. And it, of course, has a 24-hour daily cycle. I think it's 23 minutes, 23 hours, 56 minutes, 4 seconds is the exact time, but I might be off by a couple of seconds there, so don't quote me. It does have an axial tilt of 23.5 degrees. If it didn't, we wouldn't have the seasons as we do today. So in Earth's orbit, we do have a perihelion and an aphelion. So we do have a time when we are approaching the sun a little bit closer, and another time when we are a little bit farther away from the sun. When we look at whether it's summer or winter here, when the Earth is tilted towards the sun, it is our summertime in the northern hemisphere, even though we are at our aphelion. So we are the farthest point away from the sun, in the middle of our summer there. Of course, as the Earth goes around the sun, goes to the other side, we're now facing away from the Earth. It's our winter, even though we are a little bit closer to the Earth. So it's an interesting, it's a little bit of an odd statement there. You're closest when it's winter and you're farthest when it's summer. But it has to do with the tilt and which direction you are facing and the number of hours of light you get per day. Fourth planet in line from the sun is Mars. It is named after the god of war. It is a red color, and it actually appears red in the sky when you are looking at it. 1 year on Mars is 1.88 years, so almost 2 years to go around the sun once. It has two naturally occurring satellites. Phobos and Deimos, as I mentioned already. Those two satellites they actually think are captured asteroids, which is probably what they are. They are, however, on an orbit that is decaying. And so in several million years, they are going to crash into the planet, and we'll see what happens there. It does have a very thin atmosphere. Most of it is carbon dioxide, 2.7% of it being nitrogen, 1.6% being argon gas. And then of course there's going to be some other trace elements in the atmosphere. It's certainly not something that we would have, or that we could say is habitable, by certainly by humans, not habitable. But there's talk of terraforming Mars and other things like that, which is interesting. So the temperatures can range, so they can range anywhere between 20 degrees Celsius, which I think is a pretty nice temperature to be outside. But in the coldest regions, of course, it reaches a minus 153, a little chilly for my liking there. It is red in color because of the iron oxide, the rust color that you get there, that's produced from the oxygen being trapped up in the rocks that make up Mars itself. Now, Mars's atmosphere is really thin, and one thought on this is that it's so thin because it doesn't have a lot of mass. It's a lot smaller than the Earth is, and so because it doesn't have as much mass, it's not able to hold on to the gases that make up the atmosphere, and they get blown off by the solar winds. So that's Mars. Immediately after Mars, you don't actually have planets for actually quite a long way. You have the asteroid belt. So the asteroid belt, the word asteroid means star-like. They shine, but they do not produce their own light. They do reflect that, and so these are failed planets, if you will. The asteroid belt is home to countless asteroids of varying sizes. The largest one is Ceres at 950 kilometers across. And the asteroid belt it lies between the orbits of Mars and Jupiter, and there's a lot of questions as to why it exists there, likely because of an even tug between Jupiter and the Sun. It's a lot closer to Jupiter than it is to the Sun, but the tug, the pull, their gravitational pull would probably be around the same in that spot of the solar system there. I do want to just chat very quickly about a myth there. So I'm sure you guys have seen movies where they fly through the asteroid belt and it seems like they're trying to dodge asteroids. The average distance between asteroids is over 1 million kilometers. So it's not like you're going to have to dodge asteroids as you walk through. Or fly through them using your spacecraft. So that's also why when we send our probes to the other planets, we never really had to worry about hitting anything, because the likelihood of hitting something is very, very, very rare. Here is Jupiter. That is the king of the planets. It is by far the largest planet in the solar system. In fact, it's so large it could fit all of the other planets inside of it. It's named after the Roman king of the gods, Jupiter, or Zeus, if you were talking about Greek mythology there. 1 year on Jupiter is 12 years on Earth. Now, this picture that I've added here, really nice picture. This is an actual photograph from the Juno spacecraft. And the Juno spacecraft is a spacecraft that is currently orbiting Jupiter, and it's actually going through very close flybys in the upper atmosphere of Jupiter to get some measurements, and of course produce these absolutely magnificent photos of Jupiter. I would highly suggest you go on NASA's website, look up the Juno mission, and look up the pictures from there. They just released them. They are unbelievably stunning. Uh, its atmosphere is very, very, very thick. It is primarily made up of hydrogen and methane. Um, when you go, if you could go into Jupiter, which of course you wouldn't want to because it'd be very hostile, the gravitational pull on there is about 2.58 times that of Earth's. So we are talking about very, very, very high amounts of gravity there. If you're 200 pounds on Earth, you step onto Jupiter, or you get into Jupiter, and all of a sudden your weight goes from 200 pounds to 500 pounds. So you'd be crushed very quickly on Jupiter. They actually just discovered on Jupiter as well. They discovered a metallic hydrogen in the core, and it's based on pressures and stuff like that. So stay tuned. I might be able to find some articles on that because that was just a recent thing. Then, of course, we have probably what people would consider as the most beautiful planet. We have Saturn and its stunning ring system. It is named after the Roman god Saturn. The rings of Saturn were discovered in the 1600s by Galileo. He did a lot of the discoveries. He also discovered the four major moons of Jupiter. That's why they're called the Galilean moons. And he did discover the rings of Saturn. Now, the rings of Saturn, there's going to be a whole lesson a little bit further on as to why rings form, how they form, why they have little stripes as they appear here, and whatnot. So we'll get into that a little bit later. 1 year on Saturn is 29.5 years on Earth. So if I was on Saturn, I would be 1 and a bit years old right now. So that's interesting. Um, it has a very, very, very interesting feature. If you look at the top of Saturn, and if you do have a chance, go look at the Cassini mission pictures. At the top of Saturn, there is this structure, and it's actually forming a perfect hexagon. So it's interesting because it's actually got straight edges, and you can kind of see it in this photo, but there's a lot better photos of it. That they actually don't know why that forms, which is really interesting there. So go have a look at the hexagon of Saturn. If you were to Google it, it'll come up. It's a really interesting pictures there and structure. Of course, the next one is Uranus. This is named after, of course, the Roman god Uranus. The planet appears to be lying on its side. In fact, when you look at most planets, let's say this was Earth, it would rotate in this direction all the way around. With regards to Uranus, it's rotating in this direction, so up and down. And they actually think that that happened because it must have hit something very, very, very large and absorbed it a long, long, long time ago. Uranus takes about 84 years to go around the sun once. And as I mentioned already, it's tilted almost 90 degrees, which means that whatever position it is in terms of the sun, the one side of the planet is always on the dark side, the other side of the planet is always on the light, because it's, of course, rotating not in the plane of the other planets, but and perpendicular to that plane, which is really interesting. It's also a very, very, very cold place. Last planet that we consider a planet is Neptune. It's named after the Roman god of the sea. It has 8 moons with a very faint ring system. In fact, all of the gas giants do have a rings. None of them are, of course, as spectacular as Saturn, but they do all have ring systems. 1 year on Neptune is 165 years on Earth. It is by far the coldest planet. So you can actually see it has very active weather, very, very, very high winds in terms of their velocities. It's got this very bright blue, almost like a royal blue color, and that royal blue color is caused by the methane that's inside the atmosphere there. So that's Neptune, and you can understand why they called it the Roman god of the sea, because it's got that nice blue color. A little bit further out, a former planet, but planet nonetheless. That is Pluto. Now, Pluto is a minor planet or a dwarf planet. And I've included a couple of photos here. So the first photo is this one up here. So this was our first view of Pluto, what it looked like not too long ago. So we had this red dot here, and there's another red dot here. It's kind of blocked by this, and I don't know why I can't move this thing. But in any case, another red dot here. When you look at that, that's actually Pluto and its moon Charon or Charon. And then you go to the next picture here, and you see that Pluto actually has a spectacular look to it. This picture was taken by the New Horizons spacecraft, which actually passed by Pluto in, I think it was 2016, and then has now gone beyond Pluto and entered what we call the Kuiper Belt, and it actually just on January 1st of this year just interacted with another Kuiper Belt object. Stay tuned. I will post some stuff on that discovery there. And it actually that discovery by that New Horizons spacecraft allowed us to kind of understand how coalescing of large bodies in the solar system works. So at once we thought it might have been a very violent event, but by the looks of this object here that they found and visited with the New Horizons spacecraft, it actually looks like it wasn't as violent as people may have thought. In any case, the last picture here shows the Pluto system. So we have Pluto and we have Charon, but we also have 4 other moons: Styx, Nix, Kerberos, and Hydra, and they all orbit Pluto in that order. So Styx is next, then Nix, then Kerberos, and Hydra is the furthest orbiting moon of Pluto. It takes 248 years for Pluto to go around once. So it takes quite a long time for Pluto to go around, and yeah, so that's Pluto. And it is no longer a planet. Now, when we look at planets and their definition, Pluto does meet some of them. So, for example, it's rounded by its own gravity. That's an important feature of a planet. But the one thing that it does not do is it's actually part of the Kuiper Belt, which we're going to talk about next. And one of the necessary check marks for an object to be considered a planet is that it's cleared its orbital path of debris. And so Pluto has not done that, right? So it's in the Kuiper Belt as it's orbiting. It hasn't cleared up its path yet. And so maybe one day it will be reconsidered to be a planet, but it's not a planet at the moment. Speaking of the Kuiper Belt, the Kuiper Belt is another asteroid belt that's further out, and Pluto lies in its orbit. It's just outside, it starts just outside the orbit of Neptune, and Pluto actually orbits within it. In any case, there's lots and lots and lots of objects in the Kuiper Belt. It has a radius that begins anywhere from 30 astronomical units all the way up to 1,000 astronomical units. So it's a very, very, very large area there, large radius. In terms of the objects that are in there, these are icy worlds, large rocky icy worlds that are remnants from the early solar system. And as I mentioned already, Pluto is in the Kuiper Belt. Outside of the Kuiper Belt is something that we call the Oort cloud, and the Oort cloud is icy objects. It's a shell that goes around in all directions. So it's not just in the plane of the planets and the asteroid belts, but it's all around in all directions. It extends anywhere between about 1,000 astronomical units all the way out to 100,000 astronomical units. So we are talking about a very, very, very far distance out there. And so this contains millions upon millions of objects that are all trapped by the sun's gravity, but are not moving very quickly because they are so far away. And so a lot of our comets might come from here. As you can see in the image, we get cometary nuclei that are all out there surrounding our sun in all directions. And that is the Oort cloud. We are going to spend some time talking about comets and talking about other small solar system bodies that you'd find in the asteroid belt and in the Oort cloud and the Kuiper belt and all that kind of stuff. So, in any case, that's an introduction to our solar system. And yeah, thanks for the lesson, and we'll see you guys on the next one.